Welcome to section 3.1, day 2, standard form. Today we're going to write linear equations in standard form. And if you recall from yesterday, standard form is where we have things in alphabetical order with our variables. So we have ax plus by equal to a number. In this case, we call it c. A, b, and c must all be integers. The leading coefficient must be positive, and a and b cannot both be 0. So a reminder what we did yesterday, graph the equation using the x and y intercepts. So you recall we want the x-intercept. If you recall, to get the x-intercept, we will replace y with 0. We get 6x plus 8 times 0 equals 24. And like I said yesterday, make sure you show that you're substituting in 0 for the y. And then we get 6x equals 24, and we divide by 6, and we get x equals 4. So our x-intercept is the point for 0. And I will plot this right away. There's 4, 0. Remember, this is my x-axis, and this is my y-axis. The next thing we do is we want to find our y-intercept. To do the y-intercept, we make x go to 0. We get 6 times 0 plus 8y equals 24. 6 times 0 is 0, so we're left with 8y equals 24. We divide by 8, and we get that y is 3. So our y-intercept is the point 0, 3. And we'll go up 3, and we will connect them with a line. And there we have graphed using the x and y intercepts from standard form. That should be a reminder of what we did yesterday. So on this slide it says write each equation in standard form. To do standard form, we must have the x and the y on the same side. And we cannot have any fractions, and our leading coefficient has to be positive. So we can do one of two things. We can get the x and y's on the same side first, or we can get rid of our fractions first. I am actually going to move my x first in this case for the first one. It doesn't matter which order you do it as long as you do your math properly. So we add 2/3 x to both sides. This is going to cancel out, and we're going to get 2/3 x plus y equals 4. Now we have a fraction with our x variable. And to get rid of the fraction, since there's only one, just multiply everything in the equation by its denominators. We're going to multiply everything by 3. 3 times 2/3 is 6/3, which becomes 2. X, 3 times y is 3y, and 3 times 4 is 12. We are now in standard form. We have it in alphabetical order. On the left, 2x plus 3y. We have no fractions, and our leading coefficient is a positive 2. Looking at the equation on the right, again, we can do one of two things. We could distribute the half into the x minus 3, or we can get rid of our fraction first. And this one, I am going to get rid of my fraction first, so I can show you how this works. So we have 1/2 on the right times x minus 3. So to get rid of our fraction, we can multiply by the reciprocal. And in this case, the reciprocal of 1/2 is we are going to multiply everything in the equation, every term by 2. So we're going to multiply this by 2, and this whole piece here by 2. And I'm doing this specifically to show you something to hopefully prevent common errors. So 2 times y is 2y. 2 times 1 is 2. 2 times this entire entity, 1/2 times x minus 3, we only have to multiply the 2 times the fraction out front. We do not have to multiply it against what's in the parentheses, because this is all one large entity. So let's just multiply 2 times half. 2 times half is 1. So we have 1 x minus 3. And I'm showing this extra step here, which you do not have to show. And if we multiply anything by 1, we get the same thing because it's our identity for multiplication. So now we have 2y plus 2 equals x minus 3. The next thing we have to do is get our variables on one side and our numbers on the other. So we're going to minus x from both sides, and we're going to subtract 2 from both sides. So now we have negative x plus 2y equals, this cancels, negative 5. We are almost in standard form, but not quite yet. We have gotten rid of the fractions, and we have our x and y on the same side, but our x has a negative coefficient, and it is our leading variable, and we cannot have a negative for our leading coefficient. So we have to multiply it, or you could divide, however you want to look at it, everything by negative 1. Negative 1 times negative x is a positive x. Negative 1 times 2y is a negative 2y. And negative 1 times negative 5 is a positive 5. We just flip all the signs. And this is my equation in standard form. There are no fractions, the leading coefficient is positive, and the x and y are in alphabetical order on the left side of our equation. Standard form is used when we graph either vertical or horizontal lines. So the first one we're going to look at is graph x equals negative 2, a vertical line. So when x equals negative 2, it doesn't matter what y is. If you notice, there is no y in this equation. So no matter what the y variable is, x is always negative 2. So that means that x is always going to be along this vertical line, negative 2. And again, remember, this is your x coordinate, your x axis, this is your y axis. So the y doesn't matter. When y is 3, x is negative 2. So when there's no y in the equation and all we have is an x variable, we will have a vertical line. It is similar for horizontal lines. We have y equals 1. It doesn't matter what x is. There is no x in our equation. So all we have is y equals 1, no matter what the x variable is. So we have 1 for our y. We have a horizontal line that crosses the y-axis at 1. And as you'll notice, it doesn't matter what the x variable is. You could have x is 1, 2, negative 3. No matter what you put in for x, because there is no x in our equation, y is always 1, no matter what x is, because there is no x in the equation. So if you ever see an equation x equals a number, it's a vertical line. And if you ever see y equals a number, it is a horizontal line. All right, a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time and hours the pool has been draining. So we want to look for our x and y intercepts from our table. And it asks, what do the intercepts mean in this situation? When you look at our table, you notice that the x is on the left column and y is in the right column of our table. So we have our x and y intercepts. Where is it going to cross x? And it crosses the x-axis when y is 0. So our x-intercept is at 14, 0. This is my x-intercept. And our y-intercept is when x is 0, which is up here, 10,080. Okay, so we have our x and y intercepts, and what do these intercepts mean? Well, if you look at this, we're talking about draining a pool, and we're talking about how long it takes to drain the pool. Well, the y-intercept tells us at time 0, it says at time x equals 0, there are 10,080 gallons of water. So that's what the pool is when it's full, or when we started draining it. Okay? The x-intercept, see if I can fit it in here. It tells us how long it takes to drain the pool. Because when we get to y equals 0, that means there's no more water in the pool. So it takes, in this case, 14 hours to drain this pool. Okay, so if we have to graph this is what we have to be careful with. We have a x and y, and we're starting at 0, so we can actually put our y-axis right on the edge of our graph. Usually you can't do this. Word problems we sometimes can. This is my y. This is my x. And this time it says that our x is time, so we want to label this. And we say that our y-axis is volume. Make sure you label. And then we need to give a scale because I don't have a box that goes over to 14, so I'm going to do every 2 hours. So make sure if you're using a scale other than 1, we show at least the first few that we can see that we're doing a scale of 2. So 2, 4, 6, 8, 10, 12, 14. This is 14 hours right here. I know this is getting a little tight. On our y-axis, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grid lines. We are going to go by 2,000 gallons per grid line because I need to fit this on my graph. So we have 2,000 the first line, then 4,000 and 6,000. I'm only going to write a few of these in, 8 and then 10. So I can fit what we have. So we have 0 going to 10,080, which is just above the 10,000 mark since we're going by 2s. So another reason why we have tables is we can't always graph directly or at nice cross points. So if we have a table, we know what our points are, even though we have to estimate where they are on the graph. So this is 8,640. So we're going to be about a third of the way up between 8 and 10. Then we have 6 is 5,760. So we're going to go 6 goes to 5,760. That'll be right around here. 10 goes to 2,880. 6, 8, 10. So we're going to be right around in the middle between 2 and 4. And then we have 14 goes to 0. Oh, I forgot 12. 12 goes to 1440. That goes right in here somewhere. And if we graph our points, we should be able to connect these pretty decently with a line, but since we're estimating, it's not going to be perfect. So if it's not perfect, don't worry about it for this type of graph. We want to be pretty close. So there is my graph, and I did make a mistake here. My line should not go past the axes. So it should stop at the y-axis, and it should stop at the x-axis. For this graph, since we have end points and start points, we do not put arrows on the ends. So there's a graph off of our table. This is what the x and y intercepts mean. You'll be asked to do this on your homework, so make sure you can do this where you can explain what the x and y intercepts mean in a word problem. We have a couple of word problems to look at. It says a festival sells ride tickets for 50 cents each and game tickets for 20 cents each. You have $5 to spend on tickets at the festival. Write and graph an equation that describes the items you can purchase. What are 3 combinations of game and ride tickets you can purchase? So what we want to do is first identify variables for our different tickets. So we're going to say our ride tickets, let's call it R. R is ride. We have game tickets, so let's call that G is game. G equals game tickets. You have $5 to spend on tickets at the festival. So we look at what our pieces are. We have 50 cents, so 0.5, you can put the 0 in there if you want, times rides, plus our 20 cents times games equals our total money, $5. Well, one thing you should notice on this, if I told you to write this in standard form, this is not in standard form yet because we have decimals and we have to have integers. So if we want to get rid of our decimals, we can multiply everything by 10. So 10 times 0.5 is 5. So we're going to multiply this all by 10. 0.2 times 10 is 2. And 5 times 10 is 50. So now we have an equation in standard form. And now we are going to solve for our different combinations of tickets that would work. When we have an equation like this, one of those things that's nice is we can see if our x and y intercepts, or in this case our r and g intercepts, work. So we're going to plug in, to find our first value, we're going to plug g is 0 and see how many ride tickets. If all we did is went on rides and played no games, how many rides could we go on? So we have 5r equals 50, and we divide by 5, and we could go on r equals 10. We could go on 10 rides and 0. So one of our combinations is 10 rides, 0 games. We do the same thing now for games. We can make our rides go to 0. We can do the same thing to see if we can use the intercept for games. So let's make our r go to 0. So 5 times 0 plus 2g equals 50. This is 0 plus 2g equals 50. And we divide by 2 on both sides, and we find that we can take and do 0 rides and 25 games. That is another combination that works. So in this case, our two intercepts work. Intercepts for rides and intercepts for games both give us combinations that come out clean, and we spend the entire $5. Now we have to find another third one that'll work. There's different ways to do this. We can do some guessing and checking. We know that 10 rides gets us a certain part. We could say, all right, let's see what happens if we just did 2 rides and see if that would work. Or we could say, well, let's try 5 rides or 4 rides. So we plug in a number and see if we get one that works. So in this case, I am going to plug in that we are going to use and take 2 rides just to see if it works. So we have 5 times 2 plus 2g equals 50. We have 10 plus 2g equals 50. Subtract 10. We get 2g equals 40. Divide by 2, and g is 20. So we have another combination that does work. 2 rides and 20 games. So there's 3 combinations. There's other combinations that work. What I recommend, if it ever asks you to find combinations that work, try your intercepts first. Set one variable at a time equal to 0 and solve for the other one. That is all for section 3.1, day 2. Today we rewrote equations into standard form, making sure our coefficients were integers, our leading coefficient was positive, the x and y were on the left side of the equation, equal to a number on the right side. We also looked at how we can use intercepts to explain word problems and what the intercepts mean. Thank you for watching, and have a nice day.